away the heat. So you're trying to heat it up to take the solder away. You need a super hot soldering iron. You're going to risk damaging other components. Not with this. Gold clamp means that you can remove the MOSFET and replace it with just a screwdriver. I mentioned the integrated audio processor. It's based upon our DSPX Mini FM product, the 4-band product. You've got removable power supplies. And I want to say a little bit about the cooling. You'd be amazed at how rubbish the cooling is on some transmitters, and it's not for me to mention any names. You take the lids off and you see there's a nice big fan at the back and a gap at the front, and the air just goes in and out. But air will always follow the path of least resistance. It won't necessarily take away the heat unless it's channeled across the heatsink. So with our cooling system, you will see on the front that the vent for the fans goes straight in underneath the heatsink. The air cannot float around and go in other places. It's drawn across the heatsink and out the back. Now, not only does this mean that the unit is cooled very efficiently, but it also means that any dirt or dust or muck that is in the air isn't settling on your components, because it's not actually even touching them. It's going straight through the heatsink to draw the heat away, which is the whole purpose of the fan. And any muck or any particles or any dirt in that just go in the front and out the back. There is no airflow over the components. You've got built-in IP. I mentioned before about how everything is IP controllable these days. Some transmitters, it's a cost option. One of my competitors, I know, charges £500 for it. We don't charge anything for it. It's on every transmitter. It's built in as standard. You've even got an emailing system built in, a telemetry system for emailing an engineer in the event of a critical alarm. So these are very complete products. We're not pushing into the high power market. I'm not going to offer you 2 or 3 amplifiers with a combiner and go for a 5 kilowatt. These are designed to come out the carton, be plugged in, be got on air with a minimum amount of fuss, and then to give years and years and years of reliability. And also designed that in the event of something going wrong, they're easy to maintain and service. Here's a little picture of gold clamp I mentioned before. You can see, if I just use the mouse, these screws here, and in fact that one has been removed in the photograph. So the top PCB has been removed, a few screws removed that, 2 screws there, out comes the MOSFET device. No soldering, no risk of damaging nearby components, very, very quick to repair. The interesting thing about gold clamp is, hopefully it's reassuring you. You're sitting there and you're thinking, that's good, that's really nice and reassuring that if one of those MOSFETs blows, it's going to be so easy to repair. True. But the truth is that in the 6 years that BW Broadcast have been offering gold clamp, well, it's not offering, that's how the transmitters are built, we're only aware of 1 or 2 applications of it in anger, because fundamentally these are so robust, these transmitters. So on the one hand, we're saying, should you ever need to replace a MOSFET device, this is a piece of cake. On the other hand, I can tell you, actually, truth is, hasn't needed to be used in anger all that too often, which is a nice thing to be able to say. Much rather be able to say that and say they're blowing all the time. So the air cooling, the fans are rated for 10 years, they're easily replaced. As I mentioned, the air is drawn straight through the heatsink and not across the PCBs. This means that muck that's in the air goes in the front and out the back. You don't need to filter it, and that has a tremendous benefit to the long-term reliability of the product. I'm sure that is one of the reasons why we're not seeing many failures. So that's basically it for BW Broadcast. So I've started in the studio, I've got you to the transmission site, and now I've given you quite a lot of what you need at the transmission site, the audio processor, the RDS encoder, and if you're into low power, a low power FM. And that was going to be it until I got here yesterday, and I went to see a few of you. Some of you remembered me from my previous visits, and they said, so Guy, what are you doing now? And I said, oh, I'm working for a few companies. And I rattled off those companies, and I mentioned another company called Onetastic. A few people went, who? Went, Onetastic. Well, what do they do? Digital television transmitters. And the customers I went to see yesterday all went, oh, that's interesting. So, nice surprise for me, because I didn't think it would be interesting. But it appears to me that A lot of you in the room are interested in TV transmitters. Some of you operate TV stations. You've got digital sort of looming. You don't know when the regulator's going to approve it. You don't know if it's going to be DVB-T, DVB-T2, DMB-T, ISDB. You're sitting here and you're thinking, well, we don't know when it's going to happen. We don't know what it's going to be. But believe you me, it will happen. And when it does, we're going to need to do something, and probably do something quite quickly. So I'm going to introduce Onetastic to you, and you'll see why. Why I think it's relevant to the Sri Lankan market. So first of all, a bit about the company. That's a map of Italy, and you can see it's right up in the north of Italy. If you go onto the motorway and take the wrong lane, you're in Switzerland. If you go onto the motorway and take the other wrong lane, you're in Germany. If you go onto the motorway and take the other wrong lane, you're in France. I love that. As an Englishman, what's the worst that can happen? You get to the coast. You get to the sea. Same here in Sri Lanka. You can't take a wrong turning and find yourself in another country. But the important thing about that is that we can recruit engineers from Germany, from Switzerland, and from France, as well as from Italy. And Italy has a fantastic history in transmission design. But sometimes the engineering can be a little bit loose. Swiss engineering, German engineering is very much appreciated. So we try and bring some of the best of that into the company. The company was founded by two gentlemen who have a long history in this business. Their names are reasonably well known. I think between them they've got about 50 years, 25 years each in the business. And they started Onetastic as a new company 5 years ago with a brief to design from scratch a complete new range. It's not a copy of anybody else's transmitters. It's not a copy of any company's transmitters that they were associated with before. A complete new range from the ground up. And in 4 years, they have brought to market a complete range. Now, to do that, you need some pretty deep pockets, some good investors. So the company has some backing from the Albert Group, which is a very big group of companies in the military and telecommunications industry, both of which are far bigger than broadcast. Part of the Albert Group is also Telsat, so that's systems integration, and also some of the components that we need. So Onetastic doesn't stand on its own. It's got the backing of some good companies behind us. But it's a niche business, and we had to have a unique philosophy. There's 2 or 3 things about the philosophy which are unique. The first is a zero cable philosophy. Take the lid off, I'll show you some photos of the insides. There are no cables. Everything is modular, clicks together, solidly, tightly, beautifully engineered. There's no soldering, there's no cabling at all. The other thing was to design the modulator, the exciter, totally in-house and to support every digital emission standard that we could think of. So at the moment, today, we are supporting DVB-T, DVB-T2, ISDB-T, as well as analog. And it is simply a firmware change to switch from one to the other. So you could take it as an analog transmitter today, and you could go on air with DVB-T2 or ISDB, whichever your regulator picks, just by changing the firmware at the appropriate time. The other thing which is unique is the integration of many of the different things you need in your transmitter in a single box. So how are you distributing to digital television to a transmitter? It's a DVB-T2 or ISDB transport stream. It's not video, it's a transport stream. It's already been encoded, it's been multiplexed, there's metadata in there. How does it get to the transmitter? Typically over satellite or over IP networks. And we have a built-in IP receiver and a built-in satellite receiver. These are options. You wouldn't necessarily need both. You can have both if you want. And for ISDB, we have also a BTS adapter. All of this in a 1U box for up to 130 watts. So just think about that, because no one else gets close. Here you can see how everything slides together. So that photo has the RF pack removed, and you just push it in. Power supply, slide in. GPS receiver, slide in. Main controller board, modulation boards, input cards, and they just click together. You can actually assemble the unit from those pieces on your bench in about 3 minutes. You can assemble a finished transmitter. So again, thinking back to some of the points I was making about the BW broadcast FM transmitters, in the event of having to service or maintain it, your downtime is minimal. Now, as the range develops, you'll see we go up to quite high-powered transmitters. We always use the same input boards, the exciter boards, the GPS boards, the controller cards. They are the same. So you can have a common spares kit looking after a number of different sites at different power levels. So here is the one new product. You can see on the left the satellite receiver board, even with a cam card interface on it for conditional access. And this is the Dualcast board. So you've got analog inputs and IP ASI inputs. It's got a little touch screen for controlling it on the front panel, and it's also web controlled. Now, at the request of our first and biggest customer, who happened to be NEC, specific request, please don't make any parameters possible to be changed from the front panel. So that is a specific request. At the moment, the design follows that philosophy. You can interrogate the unit, you can see what all the parameters are, you can see what any conditions are, any problems in the front panel. You cannot change anything. You just need to have a laptop with you, open up a laptop, connect it with an Ethernet cable for configuration. If the market wants us to change that, we'll take that on board. So in 1U, we can ship up to 130 watts. Remember, this is digital. So that's equivalent to about 4 or 5 times that in terms of analog coverage. High efficiency, wideband UHF. About 2 years ago, I was at NAB. And one of the big DVB-T2 manufacturers was going on and on and on about a technology called Dohertune. Dohertune is quite impressive. It gives a really big efficiency gain. Television transmitters are not the most efficient. But the problem with Doherty is that it is narrowband, has to be tuned at the factory. So if you've got a number of transmitters on different frequencies, you're going to have a different spares kit for every single one of them because the RF section is tuned. We're the first people to get this technology working on a wideband basis. So it is wideband, high efficiency. On a 130 watts transmitter, you're going to save about 200 watts per hour. It's not a lot, but as you go up the scale, you'll see that this technology really can begin to save you quite a lot in your operating costs. But also it means you've got less heat, so you're also going to put less strain on the air conditioning, and also less strain on your power supply. It's not just about the efficiency of the transmitter itself. So that's the back. There's not really a lot to tell you. Fans and GPS connection. Let's move on. That's the 350 watt in 2U. Now, at 350 watt and upwards, people begin to worry about redundancy. So we've talked about swappable boards and slide in this and that and the other. It's also available with dual power supply. So that's the 3U model. Whoops. Let's go back one. I don't think it's a full photo of it. But the 3U model is exactly the same, but as dual power supply. Hello. There we go, previous. That's the back of the 3U model. Once we get to 800 watts, it's no longer an all-in-one box solution. And this is really, again, for reasons of redundancy. What you see there is 2 exciters and an amplifier. So it's a dual drive transmitter. But there's no switching matrix needed because the amplifier, which is 800 watt, has a switching matrix built in. If you wish, we can quote that as a single drive solution with just 1 exciter. We don't like to. We always like to recommend that there's some redundancy once you get to this kind of power level. So it's a dual drive solution, but it can be offered as a single drive. Now, because we're using this Doherty technology on a wideband basis, look at this figure here. At 800 watts, we're saving you 150 watts per hour over any of our competitors. And to remember, others will say, oh yeah, well we've got Doherty as well. Always ask, is it narrowband or wideband? There's no one else doing wideband. And remember what that means. If it's narrowband and anything goes wrong, you've got to have spares which are unique to that transmitter. And the other transmitter for your other channel that's in the same rack can't use the same spares. It's not a great idea. Okay, so then we can build these up in the conventional sense. So with 3 800-watt amplifiers in the rack, we can easily build 1.5 kilowatts. 4, we can get to 2.2 kilowatts. 5, we can get to 3 kilowatts. That's sort of fairly conventional way of bringing you higher power levels. And these are air-cooled. For beyond 3 kilowatt, we would propose a water-cooled solution. But again, remember that with digital emission, you are effectively 4 to 5 times more efficient than analog. So that's a 3 kilowatt there would be equivalent to probably about 15 kilowatt of analog television transmission. So, pushed up to its limit of 3 kilowatt, we're saving you 8 kilowatts per hour with the efficiency gains that we've been able to introduce. This is a fun one. Somebody said to me, I think it was at the BES in Delhi 3 days ago, how did I find Onetastic? Because not many people have heard of them. And the answer is, I saw that being put in a box at the teardown day of Broadcast Asia, not last summer, the summer before. So I'd been there with sound effects, everybody was packing up, we'd loaded up the lorry, it was all going. I was walking through a nearly empty exhibition hall, and I saw this thing going in this box. And I thought, wow, that looks interesting. What's that? And I'm the sales manager's worst nightmare. The last thing you want on the last day of a trade fair is somebody coming up to you and asking for a demo when you've just unplugged it. I didn't ask him for a demo. What that is 8 transmitters. Each one is complete. It's not just the amplifier. Each one has got the satellite receiver, the ASI receiver, the exciter, and a 15-watt amplifier. But it's more than that. There's also an N+1 redundancy matrix there. That unit can operate as 7+1 redundant or 6+2 redundant with no external switching or matrixing required. Everything you need is in there. It's also GPS distribution system. If you look at the top left of the rack here, you've got a main and a backup GPS receiver, right? So that means that they can all be synchronized. With DVB-T, any digital protocol, in fact, synchronization is very, very important. So that is absolutely perfect for small communities. When digital television is rolled out, they'll want to get Colombo going instantly. They'll want to get Colombo up and running really quickly. You'll say to me, Guy, we don't have any use for Onetastic. We're going to buy a high-power transmitter. Maybe we want a quote from you. Maybe we don't want a quote from you. But as you push out to cover the other parts of Sri Lanka, you will need devices like that. That is what got me interested in the company. Now, to have from that up to 3 kilowatts from scratch in 4 years is a tremendous achievement. So there you can see the satellite inputs, the IP inputs, the ASI inputs. And in this particular configuration, you can see the TX1 says TX1 or spare. And this one is always spare. So you can either configure it as 7+1 or 6+2. So I went over to the factory and I had a look. And I'd already got pretty excited, to be honest. And I started seeing other things. I thought, that's amazing, because a television transmitter company I worked with once before would build systems, and we'd be buying in GPS systems from third parties, usually a Chinese company. We'd be buying in RF switches and ASI matrices. We made the transmitter. We didn't think it was our role to make those things. At Onetastic, all those things are also designed and built in-house. So this is basically for synchronizing multiple transmitters at the site. Those bigger transmitters have GPS built in. But imagine if you've got 5, maybe 4+1, 300-watt or 800-watt transmitters. Do you really want to buy 5 GPS receivers? 1 with a redundant backup would be fine as long as you can get it to all the transmitters in the rack. So this is a GPS receiver, an optional backup receiver, and 18 outputs. So it's a GPS receiver and distribution system to synchronize up to 18 transmitters, also with dual redundant power supply. This is an RF switch. So you need an N+1. You've got 3 transmitters maybe and 1 standby. Main one fails. One of the 3 fails. A standby kicks in. So you need to switch the RF over, but you also need to switch the input over. So this is basically switching the input signal and switching the output signal. There are 2 versions of it according to the power capacity that you need. So the 2U and the 3U, the only difference is the amount of power you can push through the RF. So I mentioned NEC. When I was at the factory, these photographs on these next few slides are not catalog photos. These aren't like professionally shot designery photos. These are photos taken of equipment racks actually at the factory when I was there. They're blue. Why blue? Because it's the house color of NEC, and NEC came to Onetastic and he said, right, there's a huge tender in Europe, 400 transmitters. Onetastic can't go for it because of qualification criteria required that the company had to have minimum 10 years experience. Onetastic was at this point in time 3 years old. NEC said, we can't go for it either. We don't have any low or mid-power products. Our high-power products are far too expensive for this market. So we want something of the quality that NEC is associated with, that we can go for this tender in Europe. So these are designed and built by Onetastic, and they were offered by NEC as NEC products, and the tender was won. Now 400 of these are out there. So there's a couple of pictures of these. This is an N+1 solution. Each transmitter is a 340 watt transmitter, the 3U version with the redundant power supply, if you remember from the earlier slides. So you've got 1, 2, 3, 4, and a backup. There's the RF switch. And behind here, you've got the passive filter and combiner system. So you've got an entire 4+1 solution with GPS receiver and distribution in a single rack. That's basically doing the same, but it's the 2U version. And in fact, that one is down-rated to 170 watts. But the same principle, 1, 2, 3, 4, and a backup, and an RF switch, and a GPS system, and a combiner and filter system in a single rack. That's down-rated even more. That's 80 watts. Again, same principle, using the 1U. But this is my favorite. I like this. This is the 800 watt. Remember I said about the 800 watt being dual drive. So there is one transmitter, and it's dual drive. So you've got dual redundant exciters on the transmitter. And you've got 1, 2, 3, 4, and a backup. So each transmitter has its own redundancy, and then you've got an N+1 redundant backup. By the time you go to 800 watts, 4+1, effectively 5 transmitters, and all the passive RF, you do need to fit it in 2 racks, but that is still small compared to what anyone else was able to offer. These were the solutions that we sold through NEC, and as I said, there's several hundred of them. So, you've got a vote of confidence there from a really well-established brand, NEC, that the quality of this engineering is superb. You've got the track record of the company going back many, many years, and importantly, in the Sri Lankan market, just remember, this will do analog, it will do DVB-T, it will do DVB-T2, and it will do ISDB-T. And you're not having to visit the sites and change hardware out. So, having come over not expecting to introduce a television transmitter, delighted to actually do exactly that and introduce a television transmitter. That's me finished. Any questions?